Hello and welcome back to another easy problem. I'm again going to try to solve this as fast as possible and sacrificing maybe going through it slowly and more thoroughly because of that. So we're dealing with a problem I haven't tried before. So this is 3289, the two sneaky numbers of Digitville. Nice, that sounds cool. So let's just see what this is about. In the town of Digitville, there was a list of numbers called nums containing integers from 0 to n-1. Each number was supposed to appear exactly once in the list. However, two mischievous numbers sneaked into an additional time, making the list longer than usual. As a town detective, your task is to find these two sneaky numbers. Return the array of size 2 containing the two numbers in any order. So piece can return to Digitville. Okay, are these numbers in the same range? And let's see. So our array is 2 longer than we think. And all of the numbers are in the range from 0 inclusive and to n exclusive. Okay, let's see. So what we can do, a very simple approach, just create a hash set, right? And what should we return? We should return the numbers that appear twice. Okay, I think we can solve this quite easily. We're just going to use our nums array itself to mark which numbers we've encountered. So we'll just iterate over all of them for I in range length nums. Now n, the value is nums at position I. Now what we're going to do is we're just going to flip the sign on any of the digits that we've seen before. And if we find a digit that already has a negative sign, that means that's one of the duplicates, right? Now we have to be careful with the 0. And we have the duplicates. And we have to check in the end whether we found a 0 or not, because if we didn't find it, that means we have a 0. So while length duplicates is unequal to smaller than 2, duplicates append 0. Return duplicates at the end. So that's what we're going to do. And then here, all we do is if nums at position n is smaller than 0, that means we found a duplicate. And the duplicate is actually n. Otherwise, we're going to do nums at position n. Well, we're going to make it negative by multiplying with -1. So I think that should be it. O of n time O of 1 space. Let's see if that works. Wrong answer. Oh no, wrong answer. Let's see. Output 0 and 3, 2 and 3. Oh, let's see. Nums length plus 2. Okay, let's go through this example. So we have 0. So this doesn't do anything. 0, 1, 2, 3. So we flip at position 3 to negative. Oh. We have to take the positive value here when we take the number out. Otherwise, our pointers are going to be, our indices are going to be all over the place. Okay, cool. Accepted. Submit. Wrong answer. Oh my God, no. Expected 0, 1. Oh, now we have another case where the thing that we flipped is actually... Okay, cool. Never mind. So what we'll do, we'll make it easier for us. For I in range len nums, we're just going to increase every one of them. Nums at position I plus equals 1. So now we don't have to deal with the duplicates, but we have to deal with the off by 1 thing. So n, we have to subtract 1. If then we append the duplicate n. Otherwise, we're going to multiply it by 10 the duplicates. We put in the correct duplicate and run this. So even when you go fast, you can, of course, run into errors. Right. So yeah. So that's that one. I don't know if that was a successful fast solve. Probably took a little longer because of the error. But anyways, on to the next one.